Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Hi, I'm Bill Nye. For this episode, we will please introduce my new friend, 2Pi.
Hi there, and welcome to the show. My name's 2Pi the Math Guy. Today we're here to learn about calculus. Calculus is math that we can actually use to solve real-life problems, like the speed of a car, or figuring out how to effectively use materials to do things. There are two types of calculus, differential calculus and integral calculus. But for today, we'll be focusing on differential calculus. But first, we should go back to the beginning.
No, 2Pi, not that far back.
Limits are an important tool to finding derivatives and understanding what they mean to us. Normally, you have to use limits to figure out where an equation is at a certain point. But by using this equation, to find the slope of the equation at point x, also known as a derivative. For example, we can use this equation to help us find the slope of the function e to the x. Where'd it go?
It was probably the crazy lady.
We need to get security on that soon, please. We have the slope.
The squeeze theorem, also known as the sandwich theorem, helps us figure out the limit of a function by splitting it into two separate parts. The function g is represented by this thick piece of bread. You can split up g into f and h. If the limit of both of these equations is the same as x approaches a point c, the ham on our sandwich, then the limit of g will also be the same. G of x will always be between f of x and h of x, except at x equals c, where the limit will be the same. F of x is on the bottom, h of x is on the top, and together they sandwich g of x in the middle.
Here's a fun experiment to try at home to better understand and learn continuity. Take a piece of string, tie it at two ends. Make a shape out of the string that will represent your function. Take a point, call it point A. If the limit as x approaches A exists and x exists at A and they equal each other, then it is continuous. Notice how on the string there is never any breaks, holes, or jumps. Therefore, it is continuous function.
When talking about continuity, it's extremely important to mention the intermediate value theorem. This means that a continuous function over the interval a to b and has a domain of f of a, f of b, then it has every y value in between f of a and f of b. So you can have a y value between here, or here, or here, or here, or here, or even there. It's all over the graph between f of a and f of b. Woohoo! Slope is important. Not the slopes of the mountain, but rather the slope of a function. The entire slope of a function is known as a derivative, also known as here. It can be written several different ways. F prime of x, d over dx, and dy over dx. Knowing the slope of a function that doesn't have a constant slope, such as this one here, helps us figure out the shape of the graph, where the minimums and maximums are, or what the slope of the function is at a certain point. These are the rules for solving derivatives. Rule number 1, the constant rule. This rule states that the derivative of any constant is always equal to 0. Rule number 2. d over dx of x to the n is always equal to nx to the n minus 1. This is called the power rule. Rule number 3. The derivative of f of x plus or minus g of x is always equal to f prime plus or minus g prime of x. This is called the sum and difference rule. Rule number 4. Rule number 4 says the derivative of f of x times g of x is always equal to f prime of x times g of x plus f of x times g prime of x. This is called the product rule. Rule number 5. The derivative of f of x over g of x is always equal to g of x times f prime of x minus f of x times g prime of x all over gx squared. Now we can remember this by low d high, d meaning derivative, so low d high minus high d low over low squared. This one is called the quotient rule. Rule number 6. This rule states that the derivative of f of g of x is equal to f prime of g of x times g prime of x. This rule is called the chain rule. I guess we'll talk about minimums and maximums. So, slope is used to find minimums and maximums, which are really important when we want to find out the best way to use materials or the fastest way to do something. To find a minimum or maximum, we look at the slope. So when the slope goes from a negative slope to a positive slope, we get a minimum. When it goes from a positive slope to a negative slope, we get a maximum. Ta-da! When talking about minimums and maximums, it's extremely important to mention the extreme value theorem.
Extreme!
This theorem states that on a graph, a continuous graph over the closed interval a to b, that there are minimums and maximums along that line. Now, that could be on the line itself, if it looks like something like that, or the endpoints.
Extreme!
I'm going to talk about concavity. So, similar to minimums and maximums, concavity is where the second derivative changes from positive to negative. So, this can be found two ways. One, you could take the derivative of the derivative, also known as the second derivative, and find that that equals to 0. Or, you can find where the first derivative has its minimums and maximums that we just talked about. If the function is concave up, it looks like a happy face. If it's concave down, it looks like a sad face. Okay, well, we can use the first and second derivatives to help us solve complicated equations and see what the graphs are. We do this by taking the derivative, the first derivative, and saying where that changes from positive to negative and negative to positive. We take the derivative of that, the second derivative, and see what that goes from positive to negative and negative to positive. Respectively, that gives us the slope at each point and the concavity at each point. Therefore, we can take it, visualize, and draw the graph.
hate, differentiate. This is a job for
Implicit differentiation woman.
Oh, that's how you do it. Thanks, differentiate woman.
From all of us here at Chloe's house, I'm Tupac.
I'm Bill Nye.
And I'm implicit differentiation woman.
Yeah, see ya suckers and have a good summer.
Adios.